Students, this is the second help video for the second portion of your study guide. Taking a look, you're on pages 15, looking for that first flag, which is problem number 3 here. Let me zoom in for you. Primary thing you need to watch out for here is the fact that triangles add up to 180. Other thing you need to watch out for, the fact that triangles add up to 180, is you also should watch out for linear pairs, which also add up to 180. Share a spine, make a line. So in problem number 3, it's asking just for this section, but always get in the habit of just finding everything. I call that technique squeeze the sponge. So let's start by asking ourselves what we can find here. So step number 1, this is 92, which vertical angles, that's 92. I forgot to tell you that something you should also watch out for is vertical angles. Triangles add up to 180, so we can do this. That's 57 plus 92. That's 149, take it away from 180. And we got 31. Can also get this here. That adds up to 180. That's going to be 88. You see here that there's a right angle, so we can take 31 away from 90. That's 59. Again, triangles add up to 180. So 59 plus 30, that's 89. Take it away from 180. It's going to be 91. And once again, don't overlook the obvious, which are linear pairs even here. That's 180, which means this right here is 89. So watch out, triangles add up to 180, vertical angles, and linear pairs. Says right here, find all possible angle measures using the exterior angle sum theory. Exterior angle sum theory. Let me recap what that is for you. This says that the exterior angle, that's that blue angle, equals to the sum of the two remote interior angles. And in this case, the remote interior angles are going to be that green and purple. Remote means far away, interior means inside. So looking here at this diagram, number 6, this is our exterior angle. And it equals to the sum of the two remote ends. It's really good to color code these. And remember to make a thing equation before you make an algebra equation. So that exterior angle equals to the sum of the remote interior angles. So now I circle plug chug. This angle, right there, 8 plus 12x equals, circle plug chug, the green, 5x minus 4. And that's 47. It's really important you collect like terms. So I'm going to collect these as I can, and we're going to end up with 8 plus 12x equals 5x plus 43. Your goal is to first solve for x and then plug it back in. So I want x is on one side and numbers on the other. So I'm going to minus 5x, end up with 8 equals, 8 plus 7x equals 43. And now we minus 8 both sides. We end up with 7x equals 35, divide by 7, and of course we get x equals 5. This is not algebra class. Life does not end at solving for x. So now we have to take that x equals 5 and find our angles. I'm going to start with this one. That's 5 times x, which is 5 minus 4. It's 25 minus 4. That's 21 degrees. Taking a look here, that's 47 degrees. We already know that. Let's see if this actually works. We're going to do 8 plus 12 times 5. That's going to be 8 plus 60. So this exterior angle equals 68 degrees. Which, let's check if that's true. 21 plus 47, 68 degrees. There's our check. But wait, there's more. I asked you to find all the angles. So that means we have to find this one too. So we're going to do 180 minus 68. And that's 112. And here 180 minus 21. And that's 159. Now you have found everything. What I recommend is go through and summarize what were the 3 main steps to this problem. It says write a statement that indicates that the triangles in each pair are congruent. So all we want is a congruency statement, but we have to align the vertices here. So for example, in number 7, I want to say a triangle is congruent to a triangle. And obviously I'm using 3 letters. So let's color code these. Ready? One sweep, I'm making blue. 2 sweeps, I'm making green. 3 sweeps, I'm making purple. So I'm going to go in the order of 1, 2, and 3. So watch. I'm going to start with the upper. I'm going to go L, K, M. That's 1, 2, 3. L, K, M. So now you have to follow the same order, 1, 2, and 3 on the other side. And the triangle down here, my 1 is K. So I'm going K, trace with me, L, G, K, L, G. I'm going from 1 sweep to 2 sweeps to 3 sweeps. Look at the order. And as long as you align the vertices, you're fine. So state if the triangles are congruent. If so, tell how you know. The congruency shortcuts that we are familiar with are side, side, side congruency, side, angle, side congruency, angle, side, angle congruency, and then angle, angle, side. Angle, side, angle, I call the hamburger. And angle, angle, side, I call the tail. So taking a look at number 9, you always want to look first for freebies. Things that are congruent even if they're not marked. And the most common one are going to be vertical angles and reflexive sides. So here I have a pair of vertical angles. So I'm going to sweep them and you put an A for angle. Only 1 for each pair. Let's sweep also what we have here. We have another pair of angles. And then we have a pair of sides. Now you ask yourself, is this a hamburger or is this a tail? That side is only touching 1 pair of angles. So this would be a tail. This would read angle, angle, side. Congruency, or side, angle, angle. If you want to go that way, you can. Here it says we want to find the value of x. Our value of x is in this equation right here, which is connected to angle 2, which is right there. So technically, we have to find the angle first. What you need to watch out for here is, remember, when you have two equal sides, you also have two equal angles. Or in class, I called it two equal arms, two equal elbows. So let's follow those arms and elbows down. We have two equal sides here. Trace them. Now trace into the corner. And you can see that these two angles are equal here. And then taking a look on this side, the hatch marks. And follow those arrows down into this corner. That means those are equal as well. Using this, we can actually find some angle measures. Let's start with what we do know. We know this outside is 131. Go ahead and sweep a 180 degrees. And we're going to do 180 minus 137. And we get 43 here. Because of the hatch marks, we know that this is also 43. I'm going to add 43 and 43, and we get 86. We take that away from 180. We get 94. That means this angle right here is 94. So when you find 94, then you should also just continue finding the vertical angles, which are congruent right across. And that's an exterior angle, adds up to the two remote ends, which in this case would be the 43s. Walk that over, it's a vertical angle, so that's 43, which means that's 43, which now you can find this angle right here, 94. Don't forget these angles on the outside, just get in the habit. That adds up to, if you sweep, watch out for the linear pairs, that adds up to 180. So that pink is going to be 180 minus 43, which is 137. Now we have found all the angles. Now we can go back and we want to specifically find angle 2, which goes right here. Says angle 2 equals 4x plus 30. Angle 2 is 94 degrees equals 4x plus 30. And then you solve from x from here. Check your answer in the back when you're done. Right here it says find the missing length indicated. We want to find I to j. Let's take a close look on what's here. We see we have hatch marks, which makes I a midpoint. And we have hatch marks here, which makes J a midpoint. Which makes the pink a mid-segment. Or mid-seg. And we know that that mid-seg is half the length of the third side it's facing. So it takes 2 JIs, that's the mid-seg, to equal 1 dB. Now we can use that information to set up an equation. We want 2, and our JI is x plus 1 equals dB, which is 3x minus 5. You're going to go through here and solve for x. And once you solve for x, you want to plug it back in both places. Again, the main quality here is that the mid-segment is half of the third side. Mid-segment, half of the third side. Say that out loud. Mid-segment, half of the third side. said each figure shows a triangle with one of its angle bisectors. Find all possible angle measures. So this is an angle bisector. Let's stretch it out. Now, very important, P is not a midpoint. No hatch marks there. Your hatch marks are back here where the angles are. So we know this is true. We know angle 1 is congruent to angle 2. Let's look at what we're given. We're told that angle 2 is negative 11 plus 4x. So negative 11 plus 4x. And we're also given the angle SQR, which is the whole thing, is going to be 7x minus 1. Let's do a thing equation first. We know angle SQR is the same as angle 1 plus angle 2. You can see that in the diagram. Now let's circle plug chug. SQR, we already know, is 7x minus 11. We do not have angle 1 directly, but since angle 1 and 2 are the same thing, we just pull down angle 2, negative 11 plus 4x. And then here's angle 2 again, negative 11 plus 4x. From here, you want to collect like terms. So we have 7x minus 11 equals 8x minus 22. You can solve for x. You know how to solve for x. Do your own algebra. And then take your value of x and plug it back in. And it should, angles 1 and 2, the value of should add up to the larger angle if you've done this correctly. In the diagram below, it shows with one or more of its medians. Now remember, a median goes from vertex to midpoint. So from vertex to the midpoint, that means S is a midpoint. Vertex to midpoint, that means R is a midpoint. It also means that we have a 2-to-1 ratio in the middle here. So the distance X to C is twice the distance of X to S. Now, let's look at what kind of information we're given here. We're given CS. Let's trace that. If you have a third color, that's very helpful. So C all the way to S is going to, for me, going to be blue. CS equals 2x minus 5, and X to S, which is this, is x minus 5. I'm going to do that in green. This works really well if you color code it of some sort, and you do what's called a thing equation. It takes 2 to figure this one out. Let me show you what I mean. We know this is true. We know the blue segment, CS, is equal to the red segment, CX, plus the green segment, X to S. You know that's a true statement. The red plus the green equals the blue in this case. That's pretty simple to understand. We also know that the distance CX equals 2 of XS. Now, once you have all possible thing equations, then you go back and you ask yourself, where do you have numbers? We have algebra for CS. We have algebra for XS. We do not have algebra for CX, but we do have a substitute we can use. Using this, you can formulate an equation to solve for X. Let me write it down. We know CX, that's going to be 2x minus 5 equals 2 parentheses XS, which is x minus 5, plus xs, which is x minus 5. From here, you solve for x, and then you plug it in and find everything possible. Here it says, state if the three numbers can be measures of a triangle. Well, we learned in a triangle that any two sides have to be greater than the third side. So if we have a triangle here with sides A, B, and C, A plus B have to be greater than C. You can do all three combos here. Again, A plus C has to be greater than B. And then B plus C has to be greater than A. Any two sides have to add up larger than the third side. In class, I called this monkey face. So it's eyebrow, eyebrow, smiley. Let's check them. 14 plus 7 is greater than 12. 7 plus 12 has to be greater than 14. And the last one, 14 plus 12 has to be greater than 7. Now we ask ourselves, are these true statements? And the first one, that adds up, definitely bigger than 12, so that's true. Or it's actually easier just to say yes or no. So yes, that works. 7 plus 12 is greater than 14, that works. 14 plus 12, that definitely works. So for 24, yes, we know that it is a triangle for sure. Says two sides of a triangle have the following measures, find the range. So what we have here is two sides of a triangle. We have 7 and 12, and we have an unknown side, and we want to find the range that x can be in order to solve. So x is going to be less than a number, but greater than another number. So that provides us the range of possibilities that x can be. The way you do that is we do eyebrow, eyebrow, smiley. So in this case, we add a third side. So I'm going to go 7 plus 12 has to be greater than x. Next one, 7 plus x has to be greater than 7. And the last one, 12 plus x. That green, if I'm to be consistent, should be 12 plus x. And this last one is 7 plus x. Has to be greater than 12. So you solve for x each time. This first one's really easy. You just add these up and you get 19. Here we minus 12 both sides, and we get x must be greater than -5. Here we minus 7 both sides, and we have x must be greater than 5. You toss out the negative because you can't have a negative side length, so look carefully. X must be greater than 5, but less than 19. That would be your range. It said, order the sides of the triangle from shortest to longest. So we have a triangle ABC. You don't know what this triangle looks like. So let's just put our letters on here. Now let's look at our given information. C, we're told, is 40 degrees. So we put a 40 degrees here. B is 30 degrees. We're not given A, but we can find it quite easily. We just add 30 and 40. We get 70, take it away from 180. Of course, you get 110, so A is going to be 110. Now, you just need to remember this very simple thing. 1, this is not drawn to scale, so you have to look carefully at the numbers. So trace, find the smallest angle. The smallest angle, that's the small angle. In fact, I suggest you label it small. Now go across, draw an arrow, that's your short side. Small goes with short. That's your middle angle. That means this is your medium side. And of course, this is your large angle. So draw across, this is your long side. So if I were to order these from shortest to longest, my shortest side is going to be CA or AC, it doesn't matter. My medium side is going to be AB. And my longest side is going to be BC or CB, it doesn't matter. So the longest side goes across the largest angle. Longest, largest, shortest, smallest. It's always across. Here, we're going to order the angles from least to greatest. And again, we don't know what this looks like, so we're just going to draw it any way we choose to and get our numbers in here. EF is 20. And DF is 17. And DE is 23. So again, shortest, smallest. Our short side is 17. So there you trace and you find the smallest angle. That's going to be angle E is the smallest angle. $20 is the medium side, so that would make angle D the middle angle. And 23 is the long side, so that would make angle F the large angle. So the largest angle is across the longest side. It's always opposite. So you want to go through, finish all the other problems, show your work, and then check.